start the recording here. And as I said before, it's good to see everybody. I'm going to do sort of the second half of the Scratch tutorials today. And this is just in addition to the things that are already available on the website. Lots of people have been handing Scratch projects in, and most of them look really good. I try to give some minor feedback on things that can be changed, and obviously you can resubmit them if you do choose to change things. So I'm going to share my screen right now, and I'm just going to go through a few more Scratch fundamentals, as I've been referring to them. Okay, folks, confirm for me that you can indeed see Scratch the Cat.
Yep.
Okay.
Hello.
So what I want to do, first is I'm just going to do a little demonstration that uses broadcasting, because that was an area that people still felt. I got some emails that people said they still weren't quite comfortable with that, and I wrote down an example I wanted to show, and then of course I lost it. Okay, I'll figure out something on the fly. All right, so I've got Scratch the Cat here, and I'm going to add another sprite. So that's another character, and I'm just going to go to ghosts. Why not? I have to see. Ooh, centaur. Perfect. Okay, so I got Scratch the Cat, and then I've got a centaur. I will, turn the other way. The right way. And my goal for this program is going to be to have a user enter the number. I'm just going to throw a comment in here somewhere. Here's my comments list. I just forget where the comments are on this. I must have moused by it already 5 times. Oh, right click. Okay, so what we're going to do is have user enter a number. Scratch says numbers. Centaur determines if first number, second number, is a divisor of first number. Yeah, I just made that off the top of my head, so be the best example, but it's what we're going to go with. All right. So that's kind of our goal. That's not really a great algorithm, but I always recommend just taking a little jot note and writing down the things that you need to do and the order in which you need to do them. It makes your programming life so much easier. So I'm going to need variables. I'm going to need variables for, I'll just call it X and Y. Okay, Scratch, saying instruction, ask question, store values, centaur broadcast, centaur receives, does math, gets results. So that took that algorithm, that rough algorithm, took about 30 seconds to make, and it's going to give me a pretty clear roadmap on what I need to do from beginning to end. So it's just a strong recommendation. It doesn't take you much time to do this, but it will save you problems. Okay, so let's get to it. Scratch is going to, I should create some variables for X and Y. So I'm on my Sprite Scratch. Make sure you're on the right Sprite, because they both are going to have different coding areas. So my comment right now is in the centaur sprite. I'll go to Scratch the Cat, and as always, we're going to have a green flag in there. And I said we need a couple variables. So I'll make an X variable, and I'll make a Y variable. And those will show up here. And what was next on my list? Say instructions. Okay, so let's go to looks, and we'll say my centaur will be magical. So what I will do is I will have my centaur say first. And a magical centaur, I will go into ghost mode until you call upon me. Words. And then let's make him hide. Alrighty. We'll show him at the beginning. So centaur is going to say that. And then, you know what? Just to do the back and forth, instead of trying to manage the weights, like the waiting period, I'm just going to use broadcasting for that too, and you'll see why in a second. Whenever I use variables, I want to make sure that I set them to 0 at the beginning of the program, so that every time you restart the program, it resets things back to what they were. I was going to have Scratch the Cat wait for a second while Centaur said his words, but it might even be easier for me just to put a little broadcast in there. So after he's done hiding, we'll broadcast a message saying, Scratch turn. Go back to Scratch, and then when Scratch receives Scratch turn, Scratch is going to give the instructions. I need you to type in 2 numbers. I will check if the first number is a factor of the second one. So those are the instructions, but now I need to take in information. So when I'm taking in input from in Scratch, I usually assign it to a variable. You don't always need to, but in this case, because I've got 2 different pieces of data, it probably makes sense for me to assign them each to a variable. So when you're getting feedback or input from the user, there is an ask and answer block. And always get them there. Probably went right by it. Where's my ask and answer? There's my ask. Light blue. Okay, so I'm going to ask, enter number 1. And it waits by default, and all that does is wait until you type something in and hit enter. So once I get a number, I'm going to assign it to the variable. So I'm going to change, or set, doesn't really matter. Set, actually doesn't matter, set x, that'll be the first number, to, instead of putting a number in here manually, like I set it to 0 at the beginning, now I want to change that or set it again to whatever they type in. So whatever they type in is recorded as the answer block, and the answer block is right here. Okay. Now you can have that appearing up on your screen too, just kind of keep track of what's going on. So I'm going to set x to that answer block. Then I'm just going to duplicate this because I really want to do the same thing over again. I just want to get the second number now. So now I'm going to enter number 2. I want to find out if the first number is a factor of the second. So the second number is probably going to needs to be bigger. And this time I'm going to set y to the answer. So the answer is going to change, right? The first time the question is asked, an answer is given, an answer is assigned to x. And then when another question is asked, this answer is overwritten by the new response. So answer will keep changing based on how many times you ask your user for something. So the second time they answer the question, answer is going to be different, and I'm going to put it into y. Well, it probably will be different. You could put in the same number. After I've done that, I think I said I wanted Scratch to say the numbers. I could do that easily enough. Scratch says numbers. Okay, whatever. Variables, instruction, ask questions, store values, broadcast math. I won't say the numbers. Okay, so now at the end of Scratch's turn, what I'm going to do is I'm going to broadcast again. So I'm going to broadcast something new. So new message is going to be centaur turn. So when I broadcast centaur turn, it's going to go back to the centaur. And so I need to go and receive that in the centaur sprite. I'm just basically passing it back and forth between the two. It says broadcast scratch turn. I actually should have probably put broadcast scratch turn and wait, just so it doesn't do anything in the meantime. Now, when I receive centaur turn, I have hidden myself. So the first thing I want to do is I want to show myself. So basically, I'll come back into the screen. And then after I show myself, I want to do the math. And then I think I just want to say the answer. So the math for this one is going to involve something called modulus. And modulus might be a new term for you. So I might want to do a quick little how-to on that. I'm just going to switch over to a whiteboard screen for a brief second here. Actually, I've never used the built-in whiteboard, so we'll give it a shot here. Everybody see the whiteboard?
Yep.
Okay. Okay, so this is modular math, or the term I'm going to be using in this class most of the time is modulus. So that might be a new term. It's usually referred to in mathematics. It's like mod would be the sign, just like this would be multiplication, that would be division. The word MOD, or the letters MOD, stand for sign. How do you erase stuff? Well, that didn't work very well. Instead of me trying to learn how to use this on the fly, why don't I just go back to my tried and true. Still see it? You see green writing? Can somebody confirm that they see green writing right now?
Yeah.
Okay, thank you. So this is mod. In Python, you're going to see it referred to as the percentage sign. Now, all mod is it tells you what the remainder of a division is. So if I do 12 divided by 4, I think most people know that that's 3, and there's no remainder. Divide evenly, right? Because 3 and 4 are both factors of 12. So it's not really a math class, but I just want to do a quick little review. The way modulus is used is it determines what the remainder is. So if I were to do 12 mod 3, okay, the remainder, or the answer, is going to be 0. Because when you divide 12 by 3, the answer is 4, but the modulus, or the remainder, is 0. So whenever you see mod, just think of remainder, and then you know it's a division question. This comes more into play if we're doing something like this. If we do 5 divided by 2, our answer is 2.5. Okay, so, or if we think of it another way, if we did 5 divided by 2, just with our sort of old school long division, we've got 4, and then we would have a remainder of 1. So that's like back to grade 3, I think. But this is the part here that modulus is going to figure out. Okay, so your answer, in quotes, is going to be what the remainder is. So if I were to do 5 mod 2, basically what you're asking yourself is, how many times does 5 divide 2? And then figure out what the remainder is. So 5 divided by 2 is going to be 2. And then we know 2 times 2 is 4, which means the remainder is going to be 1. If I were to do 37 mod 4, okay, well, 37 divided by 4 is going to give you a decimal. So it means it's going to be a remainder. Basically, if there's ever a decimal, it's going to have a remainder. So what can I do to 4 to get it as close as I can to 37? Well, this would be 9 point something, right? Like the answer to the division question would be 9 point something. So, the computer will do it automatically, but what you want to do if you see it on paper is just like, how close can I get 4 to 37 using integers? So 4 times 9 is 36, so that's pretty close, which means there'd be a remainder of the difference between these two. So 37 minus 36 equals 1 again. Let's do 63 mod 12. So how are we going to multiply 12 by an integer and get it close to 63? 12 times 5 is 60, right? So if I did 12 times 5, I get 60. And that's as close as I'm going to be able to get, because if I do 12 times 6, then I'm going to get 72, and that's too high. It's always got to be, whatever you get down here, it's always got to be less than what you have here. So I can get a product of 12 times 5 equals 60, but that's as close as I can get to 63, and the difference between those two would be 3. So it's just finding the remainder, and I hope that most of our math skills are good enough to do that. Understanding it's more important actually than being able to do the math, because the computer will do the math for you. You just have to understand when to use it. One little thing to remember about modulus is the order is important. 5 mod 2, we already said was going to be 1, because 2 times 2 is 4. Difference between those two is 1. But 2 mod 5 is totally different. 2 mod 5 is equal to 2. Okay? If you ever have a smaller number at the beginning, your modulus, or the response that you're going to get, or the answer to the question, is always going to be the first number. So if I have 37 mod 2, the answer is going to be 37. And the reason for that is, remember your division statement. It's going to be how many times can I break, or how many times does 37 go into 2? Well, 37 goes into 2 0 times, which means that we're still left with 2 as a remainder, right? Or sorry, still left with, oh, did I do that wrong? It's going to be the second number, isn't it? I feel like my brain escaping my body right now. It's always going to be the first number, or it's always going to be the second number? Oh, I'm sorry. What am I doing? The first number, what am I doing? First number has to be smaller. I don't know why I had that backwards. Let's do 3 mod 37 this time. Sorry, I had it written backwards. That's why it wasn't making any sense to me. So this will be 3. Okay, so make sure when you're doing modulus, if you're doing it properly, there probably should be a larger number at the front, just like if you were doing division, and you're not doing, decimal division or fraction division. You typically have the bigger number in front, right? So 12 divided by 4, or 16 divided by the 4, or you very rarely, unless you're specifically looking at decimal answers or fractions, most of the time you won't see 4 divided by 16. I guess you're at grade level in math where you're using a lot of decimals, so that might not necessarily be the case. But just in general, when you're using mod in a computer program, you're typically going to have the larger number out front. So 3 mod 37 is 3, but 37 mod 3 is a completely different answer, because then again, we're trying to figure out how can we multiply 3 by integer to get it close to 37. If I multiply 3 by 12, I get 36, which is close to 37. So the answer to this one would be 1, because 37 minus 36 is 1. So 3 mod 37 is different than 37 mod 3. So just make sure you've got them in the right order. And typically, the larger number will be, I wrote this backwards. Typically the larger number will be in the front. And if it isn't in the front, then your answer is always going to be the front number. So if you've got a smaller number in front, that you don't need to do any math. It could be something really ugly, like 231 mod, I don't know, 1000, whatever. There we go. You don't actually have to do that math. You just say, oh, the remainder, or the mod of that is 231. So if you got a smaller number in front, these are really easy to solve. If you have the bigger number in front, then you might have to do a little trivial division work. So there's some videos on that I made in the Python section, because it becomes more important in the Python section. But I just wanted you to have some frame of reference as to what I am doing, or what I'm about to do in the Scratch program. Scratch. Okay, so what I wanted to do is I wanted to see if the number that they give me, the first number is a divisor of the second number, the second number is a divisor of the first number. I can't remember the order I put it in. Scratch will tell me. I need you to type in 2 numbers. I will check if the first number is a factor of the second number. So the second number should be bigger than the first number when we're testing it. All right, so Centaur has received the message or the broadcast that it is your turn to speak. So the first thing I'm going to do is I'm going to show myself, because I was hidden, because I'm magical. And then I'm going to do some math. So the math I have to do involves those variables. Okay, so I'm going to it also involves a decision process. So what I'm going to do is I'm going to put in an if statement, and if I need to modify this later, I can, but I'm just going to get myself started with an if statement. And every time we've got an if statement, we know there's a condition that it has to check to determine if it's true or false. If it's true, it's going to run whatever's in this first open section. If it's false, it's going to run whatever's in the second open session. So now we've got to go to the math of it and figure out what's going on here. So if a number is a divisor of another number, or a factor, sorry, of another number, we need to be able to divide it and get 0 as a remainder, which means that's why we're going to use mod. So for instance, if I put in 12 mod 4, the result of this would be 0, because 12 divided by 4 goes into 12 evenly, right? So the answer would be 3, but the remainder is 0, so the answer to this whole thing would be 0. The difference is we're not going to be hard coding numbers in here. We're going to be putting in the variables that we have. So what we were checking is the first number is a divisor of the second. So this is going to be the bigger number, the y, or at least it's supposed to be. And then the x is going to be the number that we're checking. So this would be the 12, and this would be the 4. Okay, so now what we want to check is, this is going to give us an answer. Okay, a y mod x is going to give us some numeric answer. And what we need to do is we need to check if that answer is 0. Should be equals in here. There it is. No, where's my equals? There it is. Okay, so this is what's going to help us determine if it is in fact a factor. So what I'm checking is if this number, okay, so whatever the answer is for y mod x is equal to 0, then we know that it divides evenly and there's going to be no remainder, there's no decimals. So if this is true, then we're pretty comfortable having Centaur say this is a divisor. So what I'll say is, instead of saying hello, you can also say variables. So what I will say is x, and I'm only going to say it for a second. So I'm going to say x, and then I'll duplicate that, is a divisor, I should say factor, sorry, a factor of, and I'll say, instead of x, I'll say y. So what this is going to say is it's going to say whatever the number is a factor of y. But it's only going to say that if this is true. And this is only true if y divided by x gives you no remainder. And remember that this is the remainder that we're talking about when we look at the 0. If it is false, if this is false and this number, when I divide y by x, is anything other, or the remainder is anything other than 0, then we know it's not a divisor. You know, for instance, if I said, is 5 a factor of 12, hopefully we've got enough math to know that when I do 12 divided by 5, I'm going to have a decimal. So there will be a remainder over here. The remainder is going to be 2. So if this was 12 mod 5, it's going to be 12 mod 5 is equal to 2. So 2 equals 2, or sorry, 2 equals 0 is false. So because it's false, it's not going to run the top part. It's going to run the bottom part. It only runs one of the two. It never runs them both. So I'm going to copy this whole chunk of what the Centaur says, and this time I'm going to say that x is not a factor of y. So those are only two options. And you know, this program just is using broadcasting to kind of show you how you can use it to bounce back and forth between sprites and use logic to determine the flow of your program. So when we start our program, I believe the very first thing it's going to do is going to set our variables to 0, so that we don't start with values already in there. Because if you don't do this, it's going to remember the values you had the last time you ran the program, and that's going to cause you some problems. Okay, so the first thing that happens on this side is Mr. Centaur is going to be visible, and it's going to say, I'm a magic centaur, I'm going into ghost mode. So you tell me I need to come back, and then he's going to hide, and he's going to broadcast, okay, I'm passing it off to you, Scratch. Scratch is going to receive that broadcast. I need you to type in 2 numbers. I'm going to check if the first one is a factor of the second. It's going to ask for number 1, store it. Ask for number 2, store it. And then say, hey, Centaur, back to you. Centaur is going to say, okay, I received my message. Now I'm going to show myself again. I'm going to do the math, and then I'm going to give the user an answer. So let's see if it works, and if it doesn't work, let's see if we can fix it. I am Magical Centaur. We'll go into ghost mode. I am gone. I need you to type in two numbers, blah, 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 blah. Enter number 1. I'm checking if number 1 is a factor of number 2. So I'm going to put in the smaller number here. I'm going to ask, is 6 a factor of 12? And I have it moving very quickly, and it did the math, and it said that x is 6, y is 12. It says the answer is 12 because the answer is the last thing that the user input. So the second question that was asked was enter number 2, and then the answer is going to be whatever the person typed in. So that's why the answer state is 12. The answer is only going to change if you overwrite it. So I would have to ask a third question, and then I'd get a new value for answer. I had my Centaur talking really quickly here, so I'm going to change those to 0.5. Twice as long on the screen. One more thing I'm going to do is I'm going to create another variable. This variable is completely unnecessary, but what I want to do is just show you what's happening when it does the calculation for what the modulus is. I'm going to have that displayed just so you can see what it's using in this box in order to determine if it's going to run the first portion or if it's going to run the second portion. So even before I do this chunk here, I'm going to set the variable. Well, actually, I should go back to Scratch and set modulus answer to 0 at the beginning of my program. Every time you add a variable, you usually want to put it at the front there, so you make sure you reset it every time. And then I'm going to do a set modular answer to, and I'm just going to copy this little chunk right here. So I'm going to set the modular answer to y mod x, just so I can show you what the answer is going to be there, and then it'll use it behind the scenes to determine what it's going to run, which section of the if statement it's going to run. So let's go back to our full screen control. Let's run it again, see if things are happening. Magical Centaur gives instructions, goes away. Need you to type in two numbers. This time we'll type in something that's not going to work out nicely. Okay, so my first number is going to be a 1, and my second number is going to be a 12. And we know that 12 divided by 5 is going to give us a decimal, which means that our modulus, okay, is 2. And the reason the modulus is 2 is because if I do 12 mod 5, okay, 5 times 2 is 10. And that's as close as I can get to 12, which means there was 2 left over, which means it's not a factor. And Mr. I'll put this 2 seconds just so I can read it a little longer. Now I can use join to join all these things together if we want to. In fact, that's probably not a bad idea because I think that shows up in one of the quizzes. So I'm going to use join operators, isn't it? Join. This is not strictly necessary, but join x and then I need another join, unfortunately, to add those two together, which is a bit of a pain in the butt, but I got to join a join. I got to join. X is not a factor of y. And then I need to say that. Say. There we go. And then I'll do something similar for the top part, except I will say, oops. In this case, it is a factor, and I'll say it for 2 seconds instead of. So the difference between these two is that before I did the join, it would just say x, and then the x would go away, and then it would say, or sorry, it would just say 5, and then it would go away, and then it would say is not a factor of, and then that would go away, and then it would say 12. So it would say 3 things, but none of them are on the same screen at the same time. Hopefully by using join here, it's joining those things together and leaving it all on the screen at the same time. I'm just gonna put a couple spaces in here so it doesn't jam it all together. Hopefully that works out. Use join very often, but in this case it might make sense. So I'm gonna do that again, And I might move Mr. Centaur back a bit so I can read his words a little better. And let's do the 12 and the 5 again. Okay, bye-bye. You should type in two numbers. Okay, so number 1 is going to be 5, and number 2 I'll make 19. So if we think about that, what can I multiply by 5 to get close to 15, or to 19 rather? And it has to be under. It can't be over. So 5 times 3 is the best I can do. 5 times 3 is 15, and the difference between 19 and 15 is 4. So my modulus answer on this one should be 4, and the Centaur should be telling me that 5 is not a factor of 19. So let's see what happens. 5 is not a factor of 19, and as you see on our modulus answer, we did indeed get 4. We'll test it again. So let's try something that we know is a divisor. So let's go, is 7 a factor of 63? Should be. It should say 7 is a factor of 63, because 7 times 9 equals 63, which means there's not going to be a remainder. And that should work for any numbers that we put in here. So I'll put in a small number at the beginning, and I'll put in a big number, or sorry, I'll put in a big number in the beginning here, and I'll put in a small number for the second number, and watch what happens to the modulus. So what we're asking here, I'm going to put in 5. What I'm asking here is 5 mod 1, 2, 3, 4, 5, 6 equal to 0? And the answer is no. Yeah, because remember, if I'm taking these numbers in reverse order, I'm taking the big number first, and the big number ideally second, and the small number first. Whereas I was writing it as big number mod small number. So it's just a bit reversed, but you can see that the mod answer is going to match the y in this case, as long as the y is the smaller number. So if I put in, doesn't matter what I put in on the front end here, if I put in 45, and then I put in 6, because it's going to check 6 mod 45 instead of 45 mod 6. So it's the modulus is going to be 6 on this one. As long as the smaller number is in the front, that's what the answer is going to be. You don't even need to do any math. Okay, now the math on this was of secondary importance. The more important part of this is, do you know how to use broadcasts? Do you know how to use if statements? Do you know how to use the basic mathematical operators, like if you're checking if things are equal or less than or greater than? Can you pick random numbers, which I'll do in a second in another example? You know, add, subtract, multiply, divide, and you know, modulus will be important. You can also round. You can do any of the normal math stuff that you can do just on paper, and the machine, obviously, the computer will do it very quickly, and you can use all of those individual blocks to do a whole lot of different things. Now, if people think it looks really simplistic and it's kind of kiddie-oriented, and you drag and drop, and you have centaurs saying stuff, but it doesn't necessarily mean that the logic is any simpler, or solving the problem is any simpler than it would be on a more complex language. We still had to solve the problem. It might have been easier for me to drag out programming blocks than actually type in a whole bunch of commands, but the act of solving the problem and writing the original algorithm wasn't any easier in Scratch than it would be for Python, right? So this is like a really important part of the process, is deciding or interpreting correctly what is the problem or that you have, what is it you want to solve, or what is it you want to code, and then making yourself some job notes and trying to put them in order so that you accomplish each chunk of your program in an orderly fashion from beginning to end, and that you can test it along the way. I didn't do a whole lot of testing along the way, but certainly if I was doing this in Python or some other very syntax-oriented language, I'd probably build a little, test a little, build a little, test a little, and you'll do that in our Reboard unit, which is coming up next. You'll find yourself doing a lot of programming and then running the program to watch what the robot does, and you know, basically he'll run until he gets into trouble, and you'll say, okay, that's where he's getting into trouble. So we'll go back to the drawing board and try a few more things and test it again. There's a lot of back and forth testing, but it's always a good idea to just jot down a little algorithm for how you think you can solve this problem, and then you can always adapt along the way. You can always change your algorithm. You can always add or subtract from your program. But to do it without a plan at the beginning is just kind of throwing a pie against the wall and seeing what sticks. And there's time and place for that as well, but it's going to take you longer. So try to do a good job on your algorithms, and I think you'll see that that transfers to better work and less work for you later when it comes to testing. Okay, I had a couple people ask me about the raindrops and how am I going to make the raindrops fall properly, and also the effect of gravity. So I'll show you how I do that, and this is more sort of basic Scratch placement of objects and whatnot. So I've got Scratch the cat here, and the other day we did a quick little tutorial on how I make him move back and forth and whatnot. So I'll just quickly jam that into place here. So if left key, okay, so if right arrow pressed, I'm gonna I'm gonna face right, and I'm gonna move 10 steps, and I'm gonna change costumes. And where's my costumes? Next, not best backstroke. Next, costume. Okay, and I'm going to have very similar logic inside the other one, which is going to be instead of right arrow, it's going to be left arrow. Next costume, set P's got to point in other direction. Remember, if he flips upside down when you do that, it's because in this direction, thingy. What's going on here? Crashing. It's crashing on me. There we go.
Yeah, Scratch can be pretty limited.
Yes, it can be, but at the same time, it does a heck of a lot more than most people think it does.
Yeah, I actually made a game, a fan game on. I did like a boss for Undertale, and I remade the boss in Scratch.
Cool. Using sprite sheets?
Actually, I just took Google Images and I was like 13. I was like, and I had like 30 days to make the entire game. And at the same time, I was new to Scratch, so I was like going through it's like that where like I was like trying to understand how the game understand how it works, and I had to like figure it out. So it's like pretty messy, like there's like some glitches, but you just have to like make sure you don't break the game.
Yeah, it's not the most powerful thing in the world, that's for sure.
I mean, it took me 30 days to make the entire game because I wanted to make something like really big, just because I thought people would think I was cool. That was the only reason why I was like making that game.
Cool. Thanks for sharing that. Anybody have any idea why my direction thing's not working here?
Oh, direction things. Oh, I actually ran into that problem. I figured it out. So, if you did you do bounce?
No, I don't think that's the problem.
Oh, okay. Wait, which project
yeah,
is
good
this?
idea. No,
Which
like when I
project?
double click on this, it should bring up my other directional options. I think maybe it just my Scratch just crashed.
Oh, I know how to fix that. Click on like movement. There's a movement.
Mm-hmm.
Okay, look down. It might be go to rotation style. And that's
Right, you can change it there. Absolutely, you can. But you can change it here as well. Oh, there it is. Now it finally popped up.
yeah, but that's freehand. That's freehand, and you're supposed to. That's by freehand.
Yep, it is. So in the so remember, if your sprite's moving upside down when you run it, it flips over. That's because you've got your rotation style set to 360, and he's going to try to flip around when you've got that one set. This one will just go left, right, and then this one I think doesn't rotate at all. He'll just keep pointing in the same direction he's pointing. So now he can moonwalk.
When fixing the scripts, can I like remove like some of the stuff that I find tricky, like annoying Like, I kind of removed the bouncing script because I felt like it was getting in the way of the script that was telling it to when it hits the corner. And I realized the bouncing script was the reason why I was stopping it from doing that, so I removed it. And just
As long as you solve the problem, I'm happy with it.
Okay.
So yeah, go ahead. As long as the end of the day you're doing what I need you to do, with regard to the output, that's fine. Okay, so got the scratch cat moving. This was just part of the rain game, but this wasn't the main part that people were asking about. The part that people were asking about was the falling rain, as well as gravity. So I figure I'll just do a little bit on that. I'll take a ball. And one thing I recommended is when you were doing your raindrops for that program, or anything that's got a bunch of repeated sprites for that matter, you really should just build one sprite that works properly. And then when you're happy with it and you've tested it and it's working right, then copy it over as many times as you need it to. So instead of drawing a whole bunch of raindrops or balls falling from the sky at once, I'm going to program one. And then after that, when I'm happy with it, I can copy it any number of times I need to. The problem with making a whole bunch of sprites at once is that if you make a change or if you got something wrong, you have to go back into each sprite and change it. So if you had a value in one sprite that was 12 and you made a mistake and it was supposed to be 10, you got to click into every single one of them to change it back to 10. Whereas if you just make one and test it and make sure it's right, then you don't have to do all that. So it's basically just preventing yourself from repeating work. So what we're going to do here is, well, Scratch say, hey, rain. So there's Scratch. He moves back and forth forever, but right at the very beginning, he'll say, looks like rain. And then that's going to send a, looks like rain for 2 seconds. Okay. And then the ball, we're going to have the ball wait a couple seconds and then start coming down. So I'm going to use timing for that. So I could use a broadcast for that, but just for the sake of simplicity, we already done lots on broadcasting. So I'll just wait. I'll just wait 2 seconds before this sprite starts. And number one, there we go. I'll wait 2 seconds before this sprite starts, and then we'll have it show. So at the beginning of the program, I'm going to hide it. So we're going to hide it at the beginning of the program, and then after 2 seconds, we'll show it. All right, so we can have a sprite start anywhere in the screen that we want to, and we could also make it random. So if I put a random feature in, so here's a random, and then also if I look up in look section, or sorry, the motion section, you notice that you can have things go to specific positions or set them to certain positions. So if I've got a set X and a set Y, remember that this is a Cartesian plane, so just pretend it's, it's math class. You've got 0, 0 in the middle, the origin, and then anything on the vertical is going to be Y values, so there's going to be positive Y values going up, negative Y values going down, and then on the left side, you're going to have like negative X values, and on the right side, you're going to have positive X values. So let's just say I want this particular ball, or raindrop, or whatever we want to call it. We always want it to start at the top of the screen, pretty much as high as we can get it. It's going to be hidden, so it's not going to be a huge deal, but let's just say I kind of put it up here. Yeah, that's as high as, probably as high as it's going to let me go. One of those sort of scratch limitations. It kind of prevents the kids from dragging stuff out and losing it, even though you can set these to whatever you want. So I'm going to look at what it's at right now, and it looks to be at negative 62 and positive 188. So here's the thing. We want it to start at the top. So I don't want to change the Y value. I want the Y value to be high. So I'm just going to set it to 190. We'll see if it'll let me start there. So I'm going to set the Y value to 190. And the X value is going to be the one that's random, because I always want it to start up high, but I don't necessarily always want it to start in the same place on the screen. I want to randomize it. So by randomizing the X value, it can start anywhere from the left side of the screen to the right side of the screen. And it's about negative 200, I think, and negative 200 on both sides. So let's just let's try to go from negative 200 to positive 200. we'll put that into set our x. So we've got our y set to the top. We've got our x set to some random place from left to right. Hide that first. I just got to get my order right here. I'm hiding. Okay, and then set it, and then show it, and then that's what I want. Actually, no, that's not what I want. I want that. So it's going to hide it, and it's going to set the position of it while it's still hidden. And then after 2 seconds, it's going to show it. It's not going to do anything. It's just going to appear on a different side of the screen. I haven't told it to fall yet. So if I run this program, Scratch is going to say, it looks like rain. There's no raindrop. And then the raindrop appears there. And then if I run it again, looks like rain. And now you notice it's in a different spot. Looks like rain. Okay, now it's even further over. Looks like rain. Now it's back here again. So it could be anywhere along the top. So that is how we determine, or that's how you can randomly pick where your raindrop is going to appear on the top. And now let's make it fall. So what's happening if the raindrop is falling is that we're changing the y value, and the y value has to go down, because anytime the y value goes down, it means the object is going downward on the screen. So what we're going to do there is we are going to change the y value. And we can do that by, see where it says change the y value? Now we can change it by a negative number. So if we change it by -10 and put it in a loop, then it will fall. So let's put this into a repeat until block, and I'll show you why I did that in a second here. So what I'm going to do is I'm going to change the y by -10, and I've got it repeating until something. So what's the until? Well, I don't want my raindrop to get to the bottom of the screen, and we're completely ignoring Scratch right now. This has nothing to do with Scratch. I'm just getting the rain to drop from the top to the bottom. We don't want our ball just to hit the bottom of the screen and then just stay there forever. We want it to disappear and ultimately, respawn up to the top again or something like that. So when we've got a repeat until, our logic condition might be until we get to a certain y point, and once we get to a certain value of y, we know we've hit the ground, and then that'll be enough. So if I just drag this manually down to here, actually it's going to bounce back up the top because I told it to go back up to the top. It's probably about -200. So let's just throw in an operator that says it's going to be less than, let's say -180. And what's less than -180? Our y value. So I'm going to go back up here and find y. So there's our y position right there. Okay, so until my y position is -180, which means the ball has gone down to the bottom of the screen, I'm going to change y by -10, which means it's going to fall at a constant rate until it gets down here, and then it's just going to stop. Okay, and there it goes, and then it stopped. I didn't tell it to do anything else. Remember, it's picking a random point to start from every time. So, this time it fell from there. This time it fell from there. It could be anywhere from left to right. So we've got it falling at a consistent rate, but what we don't have is acceleration. So I forgot I've got a two second delay on while Scratch says his thing. So I've got a random raindrop appearing at a random spot on the screen, and it's falling and it's hitting the ground. But what I want to happen is that I want the raindrop to speed up as it gets closer to the ground. So what I can do with this is I can, instead of putting a static or linear value in here where it's changing by 10 every time, I could put a variable in there. I could put a variable in there that increases or decreases. Now this isn't the only way you can do this, but it's a relatively convenient way. So what I might do is create a variable and call it speed. And you can see speed up here. And what I'm going to do is, instead of changing y by -10, I'm going to change it by speed. Now, whenever I have a variable, I should always set it to 0 at the beginning of my program, right? So my variable is going to be speed, and it's going to be set to 0 at the beginning of the program. And down here, okay, speed is going to start at 0. So it's going to change y by 0, which means it's not going to move But what I'm going to do after this, but still inside this repeat, is I'm going to change the value of speed each time so that it moves further and further the more times this loops. And what that's going to mean is every time this program loops or refreshes, speed is going to be a little bit more, it's going to be a little bit, I guess, less in this case because we're going by a negative y value. But that number, that negative number, is going to keep getting larger and larger and larger. It means the closer it gets to the bottom, the faster it's going to go. And that's more or less how gravity works. Things start at rest, and then as gravity takes over and the ball, the ball or whatever falls toward the Earth, it accelerates at 9.81 meters per second until it hits terminal velocity. That's more for your physics teacher than for me. But we're going to use roughly the same idea. And the important part is that the speed is not constant. Okay? The speed is not constant. It needs to be a velocity. It needs to have it needs to be changing. It needs to be increasing. So if I just put speed in here and I never change speed, it's going to fall at the same rate the entire time, just like as if I had -10 in here. So what I want to do is I want to change my variable each time by a negative value. So I'm going to change speed by a negative value. I'm just going to start with -2. It's probably going to fall very slowly, but it will speed up as it gets closer and closer to the bottom. But because I'm changing the y position by a speed, which is going to be going down by 2. Now remember, the speed in this case is just the number of steps it's moving downward. That's why it's a negative value. So the bigger the negative number here, the higher the speed. And you're going to see the speed change up here. It's going to start at 0. It's going to go to -2, -4, -6. It's probably going to happen very quickly. So watch what happens here. Looks like rain. And you see how it's sped up as it hit the bottom? Might not be as obvious, but what if I put at -5 in there? And then I'll just make it a large screen here. So watch the speed here now. Start slow, speeds up on the way down. Is it noticeable that it's speeding up as it gets closer to the ground? If not, instead of changing speed by 5, I could change the speed by some exponential rate. Is there an exponential? Not seeing it. I mean, I could use that, but it's not a great idea. I guess you have to use, x times x to do a square. Negative value. So I'm just thinking in my head right now how I can do this. Make it more obvious. Hopefully it's obvious. Starts slow, goes fast. It might be even more obvious if I set the size of the ball a little smaller too. It looks change set size to 50%. Might be a bit more obvious. Anyway, the point of it is because the variable speed is changing and getting more negative, the longer the program runs, it just means that the speed at which the ball is changing, the y value, which is falling, is going to increase in rate. So that's how gravity works. In the real world, eventually objects hit terminal velocity, which the air pressure or the wind coming up from the bottom negates the force of gravity, and you can't fall any faster. There's terminal velocity for human beings. If you skydive for long enough, you'll actually reach a speed where you literally can't fall any faster. You're no longer accelerating. You're just moving downward at a consistent speed. But again, that's more a physics thing. So you can learn more about that in physics class. The important part here was people wanted to know how to generate the raindrops and how to randomize where they appear on the screen, and then also how to make them accelerate as they fall down. Now, with regard, I don't want to do the whole program. I've already probably done too much of the program. I mean, a lot of the value in this is playing around with it and kind of solving the problems on your own. I've probably gone a bit too far. I'll leave it up to you to how you determine if the raindrop is hitting scratch and the score needs to change, or if scratch is hitting the raindrop. It doesn't really matter. I want to show you one pitfall with doing this rain, something that you're going to have to solve. Let's say I am happy with my raindrop, and I'm going to duplicate this sprite many times. So I say, I'm happy with my raindrops, I'm happy with the code, so I'm just going to put a whole bunch of raindrops in there and then run my program. You see the problem? They're all falling at once, right? And then once they get to the bottom, they don't do anything else. So you're going to have to put in, this is not major, this is not a particularly difficult fix. Once you've recognized that the raindrop is at the bottom of the screen, it's pretty easy to hide it. Yeah, so you can just hide your raindrop at that point because you know it'll repeat, and then after it's done this loop, it's at the bottom, you can hide it, and then you can just send it right back up to the top again. So you can actually have another loop in here. So let's do it forever. And we want it to be right there. Okay, so it's going to hide it, and then we'll get it to show it. Again, right. No, it's in there, sorry. So where it's set to pick the random, once it hits this, the end of this repeat block right here, it goes and hides it because it knows it's at the bottom of the screen. But then all of this is inside a forever loop, which means it's just going to loop back up to here again. So it's going to bring it right back up to the top, and then it's going to set the X again to a random position. Okay. And then it's going to run the exact same program again. It's going to wait 2 seconds, so it'll actually take 2 seconds to respawn. But if I get rid of that, it'll just start happening right at the beginning of the program, which is fine in this case. We don't have to wait for Scratch to say his little piece. But now when we do it, seconds. I did it on ball 7, unfortunately. Delete. This is part of the whole, you want to get it right the first time, so you don't have to go back and change a whole bunch of sprites. So ball number 7 is going to hide inside the loop. Then it's going to set X, set Y. It's going to show, and then it's going to move the Y value down. The problem is my speed. My speed is currently going to be -7,000. So that's so fast you wouldn't even be able to see it. So I'm actually going to have to set my speed back to 0 there as well. So it was actually happening. It was respawning and moving again, but it was happening so quickly you couldn't see it. So every time it loops, I need to reset my speed back to 0. Because if I don't do that, it's going to remember the speed that it had when it hit the bottom. And if that speed just continues to increase, sooner or later, it's going to be so fast that you don't even see it. So let's just see what happens here. Didn't hide here. It's probably never actually reaching this point. It's getting to -180, and then it's not hiding. It is continuing to loop. So this is looping forever, even though my Y position got down to 180. So let's just change this value, and I'll make it a little bit less. I think maybe the bottom of the screen is hurting me. Yeah, there we go. So the problem was I had to set -180, and your ball actually can't get all the way down to -180. So because it couldn't get all the way down to -180, this loop just kept happening, which meant the speed just kept changing. Now when I change this to -160, it lets the ball get to about halfway, disappeared in the bottom, and then it finishes this loop, and then it hides it, moves it back up to the top, puts it in a random position, runs it again. So what you'll notice right now is that it looks like it's raining, but it's actually just the one ball moving very quickly, resetting, accelerating, hitting the ground, resetting, accelerating, hitting the ground, and it's happening pretty quickly. So if I change this to like a -2, it might be a little bit more obvious what's happening. Okay, a raindrop starts at the top, accelerates down, disappears, respawns, but it's still only one raindrop. It looks like more than one, but it's the same one, just respawning. So if I duplicate these and then start my program again, okay, now we've got more than one raindrop, but you're still noticing a pattern. I mean, all 4 of those are respawning, and they're all accelerating as they go down, but there's clearly a pattern, and the pattern is because they're all starting at the exact same time. So what happens is if you randomize the start time, instead of the start right at the beginning of the program, let's use that wait timer. Okay, so let's go to this wait timer, and then let's put a random value in for the number of seconds it needs to start. So let's go to our operators, and we'll pick a random between 1 and, let's say, 4. So 4 seconds is a long time to wait for the first raindrop, but you'll get the idea as to what's going on here. So we're going to pick a random between 1 and 4 so that they don't all start at the same time. And of course, once again, because I made a change after I duplicated my sprite, I got to delete them all, and then I got to duplicate them all again. So that's the importance of getting it right before you start duplicating things. That's not the end of the world to have to delete and then reduplicate, but it does take some time. Okay, so first one happened right away, then the second one, then there we go. Now we're starting to get some random. Now my random number was only between 1 to 4, so it looks like a couple of them start at more or less the same time. Okay, but you could do that down to fractions of seconds, right? So if I do maybe from 0.2 to maybe 2 seconds, some random number. I don't know if it'll let me do a random decimal, but there's ways around that as well. So now they're not all falling at the same time. And that'll be more pronounced the more balls or raindrops or whatever it is you put out. So. Now this would be a reasonably challenging game. The raindrops are falling pretty quickly. The faster they fall, negative value. The faster they fall, the more difficult the game's going to be. Even more difficult. If you change it by 0.5 every time, we'll start out really slow. If you change this variable, you'll get more variance in how the raindrops are falling. Change this back. So you can play with all your values, but learn a couple more, a couple more things there. We're using randoms. We're using Y and X position in both how we move Scratch around as well as how we place objects at the top of the screen, the bottom of the screen, how we determine or how we program it so that objects will increase in speed the closer it gets to the bottom of the screen, which would be a negative 160-ish Y value. And how objects could potentially accelerate, how you can use variables and loops to continually change the variables. There's a lot of different stuff in here, how to show and add and hide stuff. And usually when I get to the end of the program, I step back a little bit and take a little break, and then I come back and I look at it. And 9 times out of 10, I'll notice things that I've done that maybe are inefficient or there's a better way to do it. And then I'll just sort of start picking apart my program and trying to make it, if it's 30 lines of code long, I'll try and make it 20 lines of code long. And you can do that sometimes, and sometimes you just kind of get to a point where it's efficient enough, it's elegant enough. But I've found that normally if I go back after the fact and have a look at what I've got, there's usually a way to shorten it to some extent, whether that's just removing a couple of blocks or changing the way a couple of blocks operate. Usually you can make it a bit more efficient. But for me, it's always important to get it working right first and then go back and then work on maybe making it a bit more efficient. So yeah, I did way too much of that project. I'm normally a big fan of sticking it in students' hands and saying, figure it out. But maybe I'm getting softer in my old age, I don't know. So that was probably reasonably quick for some people who don't have a whole lot of Scratch experience. But the videos, I record all these sessions, so they're there if you want to go back and play it over again or see what I've got on my code screen and duplicate the same thing for yourself. But there's a fair amount of technique and of the fundamental skills, description of the fundamental skills, more than enough to get you past any of the stuff that I've got assigned in module number 2. So you should be good between the tutorial videos and the training sessions and these live sessions, there shouldn't be anything that you're going to need that you don't already have in your tool bag or have access to. That's what I got for today. That's, hey, look, just over an hour and 5 minutes. That's a new record for me. Are there any questions I can answer about anything? Happy to do it.